안녕하십니까? LX
Nice to meet you. As introduced, I am Hyun Jung, Director of LX for the Standard Quality Division. It's a personal honor and pleasure to meet you all and to be able to present on the use case of National Digital Twin Standard for buildings. In Korea, currently, in efforts to tackle local challenges, we see a lot of digital twin pilot projects. They are growing in number. And for data interoperability, there is a growing need for geospatial information standards. In response to such demand, we developed in Korea a digital twin national standard to effectively and systematically share various data. You have heard Professor Hong mention the National Digital Twin Standard. Building, transportation, indoor space, terrain, and underground are the 5 domains these standards apply. We took ISO and OGC international standards, and to help fit the local environment, we're expanding and profiling these standards. Among these domains, I'd like to focus on one building domain that has been designated the National Data Standard. Now, first, we looked into the issues on standards and the National Digital Twin pilot projects. What we discovered through the pilot projects is that people working in the field find it difficult to understand and comply with existing standards. One example would be the UML diagrams. That is a common data model. The pain point was that depending on the level of understanding of people who are building data, the result in composition and quality of data had a vast difference. And the final outcome, that data end up being different as well. Also, because they use different methods, people often find it even more difficult to comply with standards or apply standards. Now, you cannot simply blame this on the standard or data itself. It is more an issue of applying standards in the process of building data. Korea's national standard conceptually defines objects. To actually build data, you need specifications that describe the build purpose, project features, or quality standards. In reality, however, on the ground, we find that many in the field face difficulty applying the national standard for product quality to define required specifications or quality standards. So we wanted to address these challenges in applying standards and challenged in building data. Toward that goal, we devised standard-based data building methodology. And this is what we came up. These are some sample data. I won't go into every detail about the project in the interest of time, but I would like to share with you some sample data that we have created. The sample data that we are created are mainly 3 types by purpose of build. First, what includes requirements on data, content, and structure. That's UML diagram. And the second is the XML schema, which defines data structure. And data encoded based on XML schema, that is GML. These 3 data are organically connected and are generated and utilized in consecutive order. So now let's take a look at samples of all 3 that I just mentioned. This sample that I will show you is based on a use case of floor size computation for a building permit. So first, take a look at this UML diagram. Starting from Korea's NDT building data model, we drafted this UML diagram to reflect the project features and requirements. The blue boxes you see on the right are where we expanded to fit this particular use case. And earlier, you would remember that I mentioned when you're trying to apply data and comply with the standards, sometimes the issue is on the level of understanding of UML diagram. And to tackle this challenge, we itemized and listed the objects on ground based on ISO 19111. These are semantic data, attribute data, and others, as you see in the list. Let me just take one example in roof data. Here, the roof surface is as identified in SiA GML 3.0 core model. That follows the same LOD there. And now you see next to each other the SiA GML 3.0 schema and the XML schema based on the NDT of Korea on buildings. We're still on the roof surface info, and you can view them as a code list as well. So the representation is optional, and code lists are commonly used in Korea in the construction field. The reason why we went with XML is because in the field, people would be able to access building data and process this data and utilize it for other purposes. And next is GML data encoded based on the previously viewed XML schema. That's the 3D building model added with some attribute data. This is a condominium apartment building that is one of the most common types of buildings seen in Korea. So let's take a look at some of the information here. There's the main wing and the sub-wing of the building marked. The use purpose of the building, other attributes defined in category are also listed there. Also, the facade and other semantic data are listed as well. Floors, which are different stories in the building, are also listed. So that was some of the sample data to show you some of the challenges we have in applying and complying with standards and a use case of National Digital Twin Standard for buildings. Now, finally, to close, the NDT for digital twins in Korea took a lot of work and thought to develop. I believe it's time for now to progress and advance to help the industries and users of all data and expand standards as well. And I hope the case that I just shared with you will help everyone connect, collaborate, and create. And it was a great pleasure to meet you all in this beautiful city, Jeonju. I hope you have a great time for the rest of the seminar. Thank you very much.